Hey folks, I want to share my newest project with you guys. So this is an power supply I just finished. It's not exactly finished, but it's almost done. So I decided to make a power supply for my lab power supply for myself. Saying this kind of a useful tool. I was looking around to buy something, then I couldn't find the specs I wanted. Um, and it kind of it's really expensive to buy really good power supplies, so I decided to build myself a one. So I will show you what this can do. Then I'll dig into more into how I made it and how everything works. Okay, you guys, I'm gonna show the main features of this power supply. So mainly I have four channels, two on this side, two on this side, and these are the main two controls for these two channels, and these are the two controls for these two channels. The middle guy is for to show what I'm pulling out of the wall, and any other information. I'll get through the menu and I'll show you what I can display over here. And these guys are basically direct outputs of the two main power supplies I have in here. So direct unregulated outputs, I directly can plug into anything I wanted and pull huge amount of current out of this. Okay, let me show you a demonstration of my one of the channels. So this guy can handle, the bottom guy can handle up to 11 amps, up to 61 volts. The top guy can do 61, 5 amps. This guy can do up to 93 volts at 5 amps. Close to at least. The bottom guy can do 10 amps at 32 volts, and each one of them has its own output switches. Okay, so I'm gonna show one of the demonstrations. So now this guy is set to 12 volts right now, and I'm gonna turn on the output. Now I'm pulling physical focus. It doesn't like to focus much. Okay, I'm sure you guys can see it. So I'm pulling right now 1 amp, and I'm gonna add up the voltage, and as you can see the amperage goes up because I have plugged this into an 8 ohm load. So as you can see, I'm pulling 160 watts, 250 watt. I can go up to 600 watts basically on this guy. Yeah, I have a small problem with the display getting corrupted, but I can show you about that later. Something I had to fix. So that's it, and so it's pretty much working. And as you can see in the middle, I'm pulling 400 watts out of the wall. This is 4 amps AC pulling, and this is the AC voltage and the voltage. Let me show you all the menu. I'm not setting. I can't set anything in here. I didn't set anything in here. It's basically will show information to you. Now these are, I have two 12 volts power supplies in here, and by each 12 volt power supply has two outputs. So as you can see, it's 12, and then I have made plugged into series with the two power supplies. So then I have 12, 24, and 24. And this guy is basically, I have a toroidal transformer in here, and so you can see the center tap is at 31 and the other tap is at 62. Usually this is more higher because I'm going to turn off the output. As you can see, it goes up to 70 volts, and the center tap goes up at about 35. Okay, that's about the main features. Oh yeah, and I'll show you the other menu items. This is the temperature, which will show, I have 11 temperature sensors in here that would show up in here, and I'm using that to control the fans. I have 3 fans on this side. and one fan in this side that blows in air, and these three pulling out of the air. I'm sure you can hear one of the fans actually running a bit. So they all temperature controlled, and and I'm checking for all the voltages in here, that so in case something goes out of whack, I'll automatically shut down the whole thing. In case either output gets shorted too much, that the voltage sag too low, especially on the toroidal transformer. It's a 700 VA transformer. I don't want to overload it. So I'm checking all the voltages. I'm checking even the how much power I'm pulling out of the wall socket, because I only can pull up to maximum about 1500 watts. So I have limited on 1500 watts. In case if I ever pull more than 1500, this will automatically shut down. Of course, in the back, I have an switch in the middle, and this is a fused socket. This is about in the back. So of course the fuse will blow in case if I'm pulling too much current, but at the same time I'm switching this off in case ever this goes over 1500 watts. This is the main power switch, and this will turn on everything. As you can see, this is not gonna take a little bit of time, because this is plugged into my toroidal transformer, and plus there's a huge amount of capacitors at the output of toroidal transformer. So because of that, this takes a bit of time. One way to shut it off is turn on the output. I will drain the capacitors. Yeah, so this is the main power switch, and when you turn it on, it will show it's self-checking. It turns on the main two power supplies, and it checks the voltage, and then turns on the toroidal transformer, and it will check the voltage. And this will not turn on if any of the voltages or something is wrong. So that's a kind of a safety feature I have built in. Yeah, let's get in. I'll show you what's inside. Okay, so this is the inside. The power supply. It looks like a lot of mess. It's kind of a mess actually, but I try to clean it up as much as I can, but there's not much space. I occupied most of the space inside here. This is pretty big. This power supply, so you can see my calipers. You can get the sense of how big this thing is. Okay, so let's get into the main two input supplies I have. This is a big toroidal transformer, 700 VA. It's really great transformer. I love it. Only issue it's really heavy. And then I have two server power supplies. I found this on eBay. I bought this mainly because of the size, and each can do 400 watts, and there's two stacked on top of each other, and there's enough space to have the air blowing through, so I don't have any issues with heating. And then the front we have the switch, and I have a small transformer here that this is the current sensing transformer. This is how I'm sensing the output, the input current, how much I'm pulling out of the wall. This took me so much time to get it working because I didn't have any experience with it, but it was a good learning experience. Then I have the main terminal on the bottom that distribute all the AC power to everything. It's like a small panel with screw terminals in it. Then I have like three things that stacked on top of each other with spaces. The top one is it's the relay that turns on the two server power supplies in here. I needed that. I'll explain a little bit later why I needed it. This one of course has a normal PC power supply, has a pin that you can pull out that would cause this to turn on, but there's an issue with it. Then I have two things. The second one, I have another one in the middle is basically I have plugged into the AC the mains, that it has a transformer, and it drops the AC voltage down to a like a 2.5 voltage, plus and minus 2.5, so then I can actually use the ADC to measure the input voltage. I needed that. I put this in so then I can actually grab a accurate how much wattage I'm pulling. And second, this toroidal transformer has two windings, input windings, so then I can put them in series to in case if I plug this into a 230 input a wall socket. I most likely I'm never going to plug that in. I'm going to never use that feature, but it's there. So I ended up needing to measure the input voltage, so that way I could switch. I have a relay board down here. It's hard to see. A four relay board that switches the input windings of the transformer, and plus I have a one of the relays I'm working it as. I have a resistor that first would turn on the relay, turn on the transformer with through a resistor. That way I'm not gonna damage my relays. So I'm doing that first, then I will actually turn on the transformer, so that way I don't have a huge inrush current. So it all works out with the measuring the input voltage and everything. So that's the main input side. Oh yeah, and I have another small power supply that's basically on. I told you there's three things on the stacked up in here. The bottom one, way at the bottom, I have a small 5-volt buck. It's not a buck. It's a switch mode power supply. It's really small that I'm using to power the standby, to give all the standby power to the unit, so that way I can turn on the main power supplies and everything else. On output side, so I have a small board here that has capacitor bank, which would smooth out the toroidal transformer, and I have a ADC in here that actually measures the toroidal transformer voltages, and I think I have this plugged into the coil, the main power sensing coil up in here. So I'm using, it has 4 channels, 8 ADC. I'm only using 2 channels to measure the toroid. I'm using one of them to measure the current I'm pulling. And this is getting communicated through I2C to the main board in here, and I have an isolation chip in here so I can isolate. So this is completely isolated. This toroidal transformer and the this servo power supply is completely isolated from each other. There's no common ground, and plus the chassis and the earth connection is completely isolated from the 2 power supplies. So on the front panel I have a ground connection here. If I wanted to ground, if I wanted to pull one of the toroidal transformer into the ground, I can do that in the front. Or if I wanted to pull one of the servo supplies into the earth, I can do that by plugging in a button plug here. I think it's pretty useful, so that I can, you know, configure however I want it. So then the main 2 output in here, I love these 2 units. I got this from eBay, and it's basically a pre-made buck converter. I have 2 of them, one on the bottom, one on the top. The top guy is 300 watts. It's a pretty simple unit. I already burned all of the both of them, and I actually managed to fix it. It's pretty simple, and I even found schematic online. So love these 2 units, and I'll leave in the description where I found this on eBay. And of course, if you're going to be using in the same kind of a configuration, especially if you have a toroidal transformer, that would go up to, in my case, go up to 70 volts when it's not on load, which caused a problem with these units because they are only meant to handle the 62 volts. One of the reasons is when you buy these units, the capacitors that comes with them, it's only rated to 65. I can't remember. It was really low. Then the total transfer definitely would shoot over the what are the designed voltages on here. So I removed the capacitors and put 100 volt capacitors in here. And the other issue is this has a switch mode buck converter to power the most of the main components. And that one has a problem too, because it's meant to only go up to 65 volts. It works pretty good. I didn't have any problems, but in case if you even load little bit over whatever the chip is manufactured to, in case if you short something out or something like that, this thing will blow, and most likely will cause most of the stuff in here to blow, because when it's catastrophically failing, it's literally giving 65 whatever 70 volts through the whole 5 volt bus in here, which will burn most of the stuff in here. So be careful, and I'll leave it in the description. The forum post I'm gonna put out. Um, um, what kind of replacement that there is to replace this. I replaced it at the same company. They have another model for the same chip that handles 80 volts. So I replaced it with that, and then I didn't have any problems with it. The second board is 600 watt one. It's basically a copy of this, but it doesn't have the output stage in here, because it has another unit, which is this guy on the top. So it's separated out, which is great because it has a gigantic heatsink at the bottom that the MOSFET is mounted to, and there's like a data cable here that connects from that to the bottom unit that talks to this and controls the voltage, which is great. I love this unit. This doesn't even heat up, which is like at 11 amps. It works really great. This guy on the top, however, I hate this tiny heatsink. I think I'm going to change the MOSFET on here. It produced so much heat. With the fan, that's why I end up having the fan down here. With even fan running full speed, this guy went at full load. It went up to, I think it was 80 Celsius on this heatsink, which is not that great, but it was stable at 80. Didn't cause any problems. So for right now, I'm just keeping it like that way, but later on I'll get back to it and I'll change it. Then I have on this front side, I have two outputs, and these two driven by I have a boost top. The top one is a boost converter, which is connected to the 24 volt rail on the server power supply, and that's guy on the bottom, and it has its own chassis, which is great. And it even has its own tiny display up in there, but I think I left it to show what's the input voltage of that 24 volt rail voltage. And of course I have a cable that plugs into the front potentiometers, so then I can change the voltage and the current, so I can control the constant current. The output is connected to an automotive relays, which is great because when I first planning this, I forgot a lot of things. One of them was the output relays, how to mount them, and do I even need one? Of course I need one. And I ended up getting this automotive relays, which is great because it comes with a nice connector and the relay on the top, which is like a socket. So I don't need to mount this into a circuit board or anything, and I can just have it dangling. Right now I just hot snapped it, and I have cable ties tied this down. So when you press this on, it'll turn on one of the relays and turns on the output. So same goes with the bottom. I have two relays up in here. So, and then I have this eBay units on the front, which just shows the current and the voltage. The top guy for the boost converter, I have a 10 turn potentiometers. This is great. I can precisely pinpoint the voltage I wanted. But the bottom guy is not, it's just normal potentiometer, because the unit I use to do the voltage conversion, the potentiometers are really high in, they're really high units, and I couldn't find 10 turn potentiometers that actually matches that spec. And I mean, there is ones out there in DigiKey and things like that, places like that, but they're really expensive. So I just end up using the normal potentiometer for that. But for right now, actually this guy is not working. All three are working right now. The bottom guy, because I actually burned it. It's supposed to go in the middle, right there, where that space is. I'll show you what the unit is. Okay, let's talk about this guy. This is one of the units that I pulled out of the fourth channel. Yeah, the fourth channel at the bottom. Um, you can buy this from eBay, and I like this at the beginning because it can handle 10 amps. The output is pretty stable, and the this actually does the boost and the buck. So I like the unit, and as you can see, I put connectors in here, JST connectors in here, so then I can pull the cable up to the front. Everything is good, but this is the second unit I have actually been through. The first unit just randomly failed. This unit, I know why it failed, because I actually accidentally unplugged one of the cables in here. I think that caused to, I don't know, I think it's since there's no limitation and there's no resistors in here, this chip basically either um, boosts the voltage too high and cause it to damage itself. So now this thing is not working either. I ended up buying a new one. I still haven't got it yet. Um, you know, when you buy something from China, it takes about forever to get here. So when it gets here, I'm just gonna put that in there, um, and see how it goes. Um, and I might decide to, if this is not gonna work out again, I might change to another unit in here. So that's that. Okay, let's get back to the main control unit. Now, this is a board that I actually uh, got it manufactured because it got really complicated, so I couldn't make it at home. It didn't cost me much. I even made like 10 boards of them. So this is what it looks like. If anyone of you guys wants this, I can send it to you. It basically has a lot of the JST connectors. Sorry, XT60, am I right? Yeah. The kind of big connectors that handle a lot of current, so this goes on the top. Then this thing focuses really hard. There you go. And then I have the 80 mega 328p that fits in there. Bunch of MOSFETs that controls the fans, and then I have the bottom. These are all JST connectors to plug in all the one-wire temperature sensors. Then I have a one-wire master here that talks in I2 to the I2C bus. Then I have a bunch of I2C connectors in here that goes to the other the toroidal transformer smoothing board, so then I can get the ADC values out there. And then I have the front display talks through the I2C. I pretty much use all the pins on the 80 mega. It's pretty much I ran out of all the pins. I literally use every pin to sense something around here. I have a relay up in here that mounts up in here that turns on these two power supplies. That's not meant to handle a lot of current. It's basically the standby switches in here that after I turn on the big relay, I turn on the two power supplies using standby relay. I use this because a relay, because that way I don't have to worry about voltages, since I'm plugging these two in series. I could easily use a relay as just a turn on switch. Then I have this front panel switches that plugs into the middle of the board, and that's about it. It's pretty sounds simple, but there's a lot of went into this design, and that's why I ended up actually manufacturing one of these, getting manufactured, because it was too complicated for me to make it at home. And worked out great. I had did few mistakes, and this is the first revision I actually made. I didn't do another round of this, but that's only a small mistakes I made. I just fixed it by bunch of wires, but that's it. So as you can see, the bottom, this is the row of JST connectors that plugs in all the 1 wire temperature sensors. I have 11 of them plugged in. 3 on the top, which is each sink has its own temperature sensor, and the bottom has 3. And I'm sensing the toroidal transformer temperature, and I'm sensing the, as you can see, the cable already goes in there. I'm sensing the heatsink temperature in here, and then I'm sensing there's 2 heat sinks on it. The one on the top, which is the unit from the second channel down there, and then I have the boost converter. I have temperature sense for that, and I have the other unit in the bottom here, which is taken out right now, that has the temperature sensor on it. So that all adds up to 11 temperature sensors. So the fan connectors on the top, then all the XT60, I think, am I right? Yeah, XT60 connectors. So these all XT connectors on the top, which is distributing power to the front, and to the 2 units that just do these 3rd and the 4th channel output. So this is basically, I'm using it as a distribution board, so I can distribute all the power down from the power supply to everything else. And I'm actually have an ADC on it, that actually 16-bit ADC that actually measuring the outputs of these 2 power supplies. It's overkill, 16-bit, but I found a good chip that actually was cheap enough. Then I ended up putting 2 of them, one of them in the smoothing, the toroidal, the power filtering pad, and into the main board. So I have 2. So I have 8 channels of 16-bit ADCs in there. That's about it. And I have gigantic capacitors in here that works with because these small capacitors didn't actually work out pretty great. So I ended up having to put a gigantic capacitors, Panasonic capacitors in there. As you can see, it's kind of hot glued in because I didn't plan that on it at the beginning. So that's one of the spaces I had to put it in there, so I ended up putting it in there. Worked out pretty good. It's not moving anywhere. And these things are fuses. These are inline fuses. I completely forgot about fuses, so I ended up actually using these inline fuses, which they worked out really great. Doesn't take much space, and I can easily swap them. It sits on this connector, and I think these are meant to go on automotive stuff, but hey, it works out really great. It handles the current that I needed. And so every output in here that has a fuse on them. Now let's talk about the case. This is an aluminum case. It's with a really thick front panel. This is really thick. Took me so much time to figure out how to cut this. I never have actually used a metal case before in any of my projects. I always used to use laser cut wood and laser cut acrylic, and but I ended up having to have anything metal because when I bought the toroidal transformer, I didn't realize how heavy this guy is. This whole unit is so heavy right now. There's no way this is gonna you can hold this by a wood case, or unless you had to use a thick wood or acrylic, laser cut acrylic. When I was first making this, I looked online. There was a bunch of people, a bunch of like companies actually. You can send them the drawing. They will actually make the case for you. I was about to do that. I actually got them quotations, and they cost you about, you know, somewhere from $400 to $500 or $600 just to get the case done. And this is a hobby project, didn't have that much of money. I could have gone with the actual power supply that's already been pre-made for that price. I ended up actually looking around and in eBay, and it took me so much time to find this case. I wanted, there's one seller that sell this case that on this size. This is the biggest size I could find on eBay. I couldn't find anything that bigger than this. And it costed me about close to $200. I guess I can, it was $150 to $200. This came in bare, basically doesn't have any holes in the front. This is thick aluminum plate, and all the side panels and the top panel doesn't have any holes on it. Only hole that they came with was the power connector. I think this is meant to put a power amplifiers. To people who make power amplifiers, they use this case and they can make however they want it, customize it, and this ended up being a really cheap choice. I mean, not exactly cheap, but since I already bought everything I wanted, I ended up paying $100 to $200 to get the case done. Came out pretty fast down here from China. Then I had the biggest problem when I tried. I thought I could just make this square cuts with a Dremel tool. That didn't work out. I'm lucky that I didn't actually damage the front panel while I was trying to do experiments on it. Only damage I did was this small damage I did in here. That's not a big a deal. I ended up buying a small mill that would fit onto my drill press. That didn't work out pretty great, just because of this drill press is cheap and didn't work out. I ended up actually spending my money on this guy, which is X-Carve. I always wanted one, so I ended up actually pulling a trigger to get one of these. That worked out pretty good. I made the front panel completely using that, and all the side panels which has the holes for the fans. This side I made a mistake on this end, but doesn't show much. But and I made that, and I made a hole to get the switch in there. It's a lot of cutting. It took me a lot of time, sometimes full day, to get just the squares cut out, because this is X-Carve and it's not meant to cut a lot of metal, but it works. It takes time, but you can get it done. So I did that. That's why that's how I made the holes, everything in here, and I did a CAD drawing and actually nicely fit. I don't have any complaints about it. So that's how I made the case. Okay. So this is one of the units that was inside the power supply, and I pulled this out because I kind of burned it, and I originally was putting two 300 watts units in it, and then I decided to use a 600 watt and a 300 watt. It's kind of worked out pretty good because I used this as a pot, a source of pots, because I burned the other one too, and especially the ADC on the STM32 microcontroller. Yeah, it uses the ADC to one ADC channel to detect all the buttons, using resistor dividers to measure the voltage and figure out what buttons being pressed. I accidentally touched a 5-volt rail onto it, and that burned the ADC. So now ADC is not working, but the unit itself is working because I fixed most of the problems. Mainly this one burned out because of the switch mode, the buck converter in here that burned out, and then that took out most of the op amps in here and everything that was connected to it, except for the main STM controller, because it runs on 3.3, so it has its own regulator. This regulator kind of saved the chip from burning out, which was great. Other than that, this is my experimental board. I'm gonna keep working on it. I ordered STM32 microcontrollers. So I'm going to replace this with the new ones that are coming in. But I'm going to try to source the binary out of the microcontroller and then put that into the new one. I mean, if it's possible. If this is if the code is being locked, or if the binary is being locked on the chip, I won't be able to get that out. But I'm going to give it a try anyway. Worst case scenario, I'm going to use it has a serial interface, so I can use that to plug into the computer and turn on the outputs and monitor the output and things like that. I thought it was just great, but the software that came with it, it's kind of pretty shitty. But if I can figure out all the protocol, the serial protocol that talking in, I should be able to talk to this and maybe write my own software for it. But that's for the future. So this is the main unit. I highly recommend people buying it. Buying it. Its output is really stable, and this one conveniently comes with all the connectors. Like for example, all the switches, it has a connector to it. For the rotary switch, this one, and it has the pin header for that. And then it even has the output sensing wires can be connected to here. So two pads are on two sides. You can desolder, so that way it disconnects the sensing from the connector from here to the. So then you can plug in any like a joystick connector and actually solder into the output connector. So then actually the unit itself knows exact voltage at the point of the connector. And top here there's a output for the LEDs, and the serial output, which is great. So I highly recommend, as I said earlier, most likely you have to do the modification, like such as getting the change the capacitors. If you're gonna go up to 70 volts or over 65 volt, which is rated to, you need to change the capacitors. And plus the capacitors came with it was pretty unknown Chinese brand, so I replaced it with Rubicons. And make sure you replace the buck converter chip, then you should be good to go. When I think about this right now after I made it, and if I can recommend this to anybody, I would not, because this actually costs a lot of money. I'm sure for the price the money I spent on this, I'm sure you can actually buy a nice, decent power supply out of shelf. And the other thing is, this is really heavy and big. Well, only good thing about I learned a lot while I was making this. If you guys have any questions, please leave a comment down in the video. I'll get back to you as I can.